First of all, by way of introduction, it's very nice to meet all of you. My name is Ian, and I'm part of the founding team here at Merkle Science, where my role today is in charge of product strategy. For those of you who are unfamiliar with Merkle Science, although I like to think that the fact that you're in this workshop, tends to mean you are familiar with us. But for those of you who aren't, quick one-liner, Merkle Science is a blockchain analytics company. We specialize in building software solutions to help both public and private sector organizations around cryptocurrency monitoring, investigations, and forensics. Now, in today's session, it's really our first session targeted at the US market, where it's intended to provide an introduction to blockchain tracing, where I will be covering, some foundational understandings of what is blockchain and cryptocurrency, because, in my experience, as great as the tools available today are, oftentimes I find that it is important for an investigator to understand a little bit about, the underlying technology, as it does influence their way of interpreting the data that is then presented to them. On top of, providing some foundational understanding about the technology, I will be introducing everybody to basic concepts when it comes to blockchain tracing, what type of data you should be looking at, where can you obtain this information, and how you can use it effectively. Whilst, Merkle Science does have its own commercial tool, I'm always a proponent of, what's available online. As great as, all the blockchain analytic providers strive to be, the reality is, the blockchain and crypto space is growing at an exponential rate. And it's almost impossible for any blockchain analytic company to provide coverage for all the different blockchains and cryptocurrencies out there. So with that said, it is very important that, an investigator is aware of the free tools available online, especially for some of the newer blockchains that, some of the providers may not have coverage for. That being said, there is, of course, a benefit to using blockchain analytic tools. And so I will be introducing everybody to what a tool is, how it works, and typically, what are some of the main benefits that you can obtain from it. And then, of course, depending on how much time we have left, I will also be sharing some practical tips and advice when it comes to tracing, right? Now, I do want to start off by also saying that this 3-hour workshop is intended more for individuals who are just starting out their career when it comes to, cryptocurrency investigations, and it's less intended for the more mature audience. So if there are, any crypto investigation gurus on the call, I do beg for your forgiveness, if we do cover some content which you are familiar with, but, what I found is that it's always a good idea to refresh your knowledge anyway. For those of you who have joined in mainly to focus more on the tool, that will be covered in the second half of the session. So just in case you want to work on something else during the first half. In terms of the specific agenda, so like I mentioned, the first hour of today's workshop will be focusing more on the theoretical aspects of blockchain and crypto. What is it? How do those transactions take place? What do those transactions look like, right? Because a large part of crypto tracing is, analyzing transaction information. So I want to make sure that everybody's familiar with what a cryptocurrency transaction looks like and where they can go to obtain this information, right? I'll talk about what are some of the main objectives when it comes to crypto tracing, right? As well as introducing everybody to some of the open source intelligence platforms available, as well as also talk about how, cryptocurrency is stored, right? So all of this will fall under the first part of the session. And then thereafter, in the middle, just before we go for a short break, I'm very proud to say that we've also invited one of our advisors to join in. So one of our advisors by the name of Matt Swenson, who's had, a long career in US public sector, with a number of years in crypto investigations. He has very kindly offered to join us for 30 minutes, where he will be sharing some of his practical experience about cryptocurrency investigations, challenges that he's faced, as well as, he will also be opening up some of his time for Q&As. So for those of you who have, more operational questions, please save them for when Matthew joins us, and he'd be happy to share his experience where relevant. That being said, throughout the entire workshop, if anybody does have any questions, please feel free to post them inside the chat or in the Q&A section accordingly. I do apologize if I don't respond to your question immediately, as I may not want to disrupt the flow of the workshop. Admittedly, we do have quite a lot to cover today, but don't worry, as long as the question is noted down somewhere inside the chat, I promise I will eventually circle back to it. And for any questions at the end that I'm unable to address because of time constraints, I'm more than happy to follow up via email. Right. So that's kind of what's going to happen in the first half of the section. And then once we come back for the break, the last 1.5 hour, we'll focus a little bit more on some more complex theoretical applications of blockchain, but then thereafter we're going to dive into some practical examples where I'll be then showing you, what a blockchain analytic tool looks like and providing you, a simple walkthrough of how a tool could be used to conduct an end-to-end crypto investigation. So with that said, I will pause here for a second to see if anybody had any questions that they maybe wanted to front load inside the chat. And whilst I'm waiting to see if we have any questions, the other thing that I will tell everybody in the audience, crypto and blockchain is a space that is evolving very fast. Even as someone who's been in the space for more than 5 years, I'm constantly learning something new every day, right? So this session, as much as I try to cover what's important, it is by no means complete and comprehensive guide to crypto forensics. There is a lot more out there for you to know, and the more that you educate yourself, not just on the tools but on the technology, it will greatly enhance your ability to conduct investigations. So with that, I do see a hand raised, so happy to take a question at the start. Nazar, and in the event that you're unable to speak, feel free to just post your question inside the chat as well. But Nazar, I see your hand raised. Do you have a question? If not, I will lower your hand and I will monitor the chat. So if you do have something, by all means, please post it inside. But if I don't see any questions, then I'm happy to go ahead and proceed and kick things off. All right, so let's dive straight into it. Right now, even though I will be focusing on introducing the foundations of crypto and blockchain, rest assured, this is not intended to be a technical course in any means or form, which means that there's no coding expected on any one of you in the audience, right? And Nazar, I do see that you've mentioned the chat is disabled. My sincerest apologies. I'm not sure why that is so, but in the meantime, if you don't mind, any questions that you guys have, just feel free to just post it inside the Q&A like what Nazar did, and I'll get somebody from the team to see if they can sort out the issue with the chat. Yeah, I do apologize, but thank you for bringing this to my attention. Cool. With that, like I said, let's go ahead and get started. So let's kick things off with something that's really very, very basic, which is, what is blockchain? And the way that I like to teach blockchain is to start off by first talking about, what is blockchain and why are people focusing on it today? Now, blockchain at its very, very core is nothing more than a new way of storing information. To be precise, blockchain is what we call a type of distributed ledger technology. I repeat, distributed ledger technology. Now, if we just take these three words, distributed, what does that mean? Well, distributed means spread out. Ledger, what is a ledger? A ledger is basically a record-keeping mechanism, right? And then technology needs no explanation. So if you take these three words together, distributed ledger technology, it seems to refer to a new way of storing information that is in a distributed manner, right? So what does that mean and why is it important? To appreciate it, I think we first need to understand how is information typically stored today. Today, most organizations that we're familiar with, the banks, the payment companies, the hospitals, all of these organizations operate on what we call a centralized ledger system, right? To take a bank for an example, the bank is the one that stores all our credit card information, our transaction information. If you wanted to pull up, your bank records, if you wanted to access how much money you had inside your savings account, you have no choice but to log in and connect to the bank's database because the bank is the only organization that houses all this information, right? And we trust them to store this information in a safe and secure manner. Hospitals work the same, right? If you wanted access to your medical records, what do? You have to log in, connect to the bank server, the hospital server, and pull up your medical records. Now, this is the traditional way of storing information that we're very used to. And whilst this has worked very well for the world for many, many years, more recently, a number of issues have emerged, namely around, security. As the world evolves and data increasingly becomes a more important and precious commodity, more and more organizations are now being susceptible to, data breaches, cyber attacks, and so on. And so for many different reasons, organizations are constantly looking for safer and more secure ways to store and share information. And this leads us to the introduction of distributed ledger technology. So what is a distributed ledger technology? Well, like I said, we just look at the name distributed ledger, it kind of already tells us what we need to know. In contrast to a centralized ledger system where everybody has to rely on one organization to store their information and access that database whenever they want their information, a distributed ledger system is instead saying, hey, rather than relying on one organization, can we build a system where we have everybody be independent parties, where everyone takes responsibility for storing the information, but we design it in such a way that all these databases are all interconnected and constantly communicating. And so what that means is rather than just having, one organization storing, all your banking transactions, all your medical records, can we set up a system where we have multiple databases all storing the bank records or storing the hospital records so that when it comes to us wanting to access the information, we don't just have one point that we can access, we can actually, call up many different organizations in order to access the information. Now, this has, many different benefits, not just from a security perspective, but also from a consistency perspective, right? In the sense that, if the bank is the only one that stores our information, anytime we want to access the information, we need to make sure that the bank is available, they're open before we can access it. Whereas in a distributed and decentralized system, if we have many organizations all around the world, all storing this information at the same time, then as long as any one of these organizations are available, we can connect to the database and access the information we want. So from a very, very high level, this is distributed ledger technology, right? It's talking about a new way of storing data where instead of storing all our information in one place, we store it in many different places. Now, tying this back to blockchain then. So blockchain is a type of distributed ledger, which means that just like how distributed ledger stores all its information in multiple copies in many different locations, blockchain is the same, right? And in a blockchain-based system, we call every copy of the data, right? So every version of this information is referred to as a node, right? So every copy of this information is what's called a node. Now, to give you guys some, statistics so you can kind of appreciate this, The Bitcoin blockchain at any given point of time has more than 10,000 nodes in operation. That means that there are more than 10,000 devices all around the world storing the exact same thing, which means that when you are conducting a cryptocurrency investigation and you need access to blockchain data, and specifically if you are conducting an investigation for Bitcoin and you needed access to Bitcoin transaction information, there's actually more than 10,000 places around the world that you could actually go to get access to this information. And all of these 10,000 plus nodes are all storing the same information. So regardless of who you ask, you should be seeing the same thing. Now, I see one question that has come in. Can a node take information out of the network? So by right, no. Right? Once something is stored inside a blockchain-based system, it cannot be taken out, it cannot be deleted, which is why one of a key characteristics of a blockchain is this concept of immutability, right? Now, how is a blockchain immutable? A blockchain is immutable because it leverages on more advanced technologies like cryptography, encryption, and so on in order to make sure that the data cannot be tampered with. Unfortunately, these concepts of encryption, cryptography, they are outside the scope of today's workshop because we only do have 3 hours, and to cover the technicals would be a little bit too much. But all you need to know is that blockchain is a way of storing information. Once information is stored inside the blockchain, it relies on advanced encryption and cryptography to make sure that once the information is stored, it cannot be changed. Now, why is blockchain given the name blockchain? A blockchain is called a blockchain because of the way in which it stores information as well. A blockchain stores information in metaphorical blocks, which means that over time, new blocks of data are created, and that block is then stored inside the blockchain. And all these blocks are kind of joined together side by side, which gives you the illusion of a chain of blocks, hence the term blockchain. Now, to give you an idea as to what is stored inside these blocks, so let's use Bitcoin for an example. Bitcoin was the first cryptocurrency ever created, and the creator of Bitcoin, who today we still don't know who that person is, the creator of Bitcoin had created the Bitcoin blockchain for the primary purpose of facilitating Bitcoin transactions, which means that inside this Bitcoin block of information, inside the Bitcoin block that is created, about 90% of the space inside that block is just filled with transaction information, right? So every time the Bitcoin blockchain creates a new block, they would store what's called a transaction hash. You can think of this kind of like a unique identifier, right, that references this block. They will have a timestamp of when this block was created, right? So all the transactions that had happened at the same time. We can ignore the difficulty and nonce that's outside the scope of today's workshop. But again, importantly, most of the information inside the block is filled with transaction information, right? Account A, send account B 1 Bitcoin, account C, send account D 1 Bitcoin, and so on and so forth. And so what we are doing as cryptocurrency investigators is we are actually trying to access all this transaction information inside the different blockchains in order to conduct our tracing exercise. Now, before we then start taking a deeper dive as to how cryptocurrency transactions actually take place, what I found to be very useful is to first actually spend 1 or 2 minutes introducing everybody as to how your typical electronic transactions take place. Because I find that a lot of people actually, as much as we use electronic transactions almost daily, through credit cards, through bank transfers, what I found is that a lot of people fail to appreciate what actually happens behind the scenes. And once we actually understand how a traditional electronic transaction takes place in, let's say, the Web2 space, it then helps us better understand how cryptocurrency transactions take place in a Web3 context. So how does a traditional wire transfer that we're familiar with take place today? Well, let's say Ian, wanted to send 1 Bitcoin to James, right? Sorry, I wanted to send $100 to James via a bank transfer, a wire transfer. Well, the first thing that I would do is, I would open up my bank app, right? And I'll initiate that transaction. What then happens is that information of me wanting to send $100 to James is then sent to my bank, and my bank will proceed to do a verification, right? Things that my bank might do is to check on my account balance. If I want to send $100 to James, well, I better have $100 inside my account, right? I shouldn't be spending money that I don't have. On top of checking simple things like that, the bank would also do, their typical compliance checks, right? Making sure that, James is not a politically exposed person, not a criminal, so on and so forth. Assuming that the checks all come back positive, I do have enough money in my bank, James isn't a criminal, the bank will then seek to process that transaction, which means that, they have to find a way to connect to the recipient bank. And so this could be through intermediary banks, potentially, right? Where my bank has to connect, to intermediary banks, provide them that information, and through the intermediary banks, it is then finally connected to the recipient bank, James Bank. James Bank would have to do the same thing, right? They would also want to verify that I sending him money, I'm not a criminal, James is okay receiving the funds. And once all of this is completed, once both my bank and James's bank is satisfied, the transaction is then confirmed, and this is the most important aspect. Once the transaction is confirmed, a record of that transaction is then created. I repeat, once a transaction is completed, a record of that transaction is then created. Now, I want to emphasize this a lot because when it comes to wire transfers today, unless a record is created, we cannot say that a transaction has gone through. And this is actually true of almost all electronic transfers, right? If there is no physical transfer of goods, right? If you don't see actual gold bars moving or cash moving, how do we know if an electronic transfer has happened? Well, the only way for us to verify that an electronic transfer has happened is through record keeping, right? So when we verify how much money we have in the bank, what do? We look up our bank statement, right? If you wanted to prove that, you've paid your vendor, that you've paid for lunch, what do? You produce a receipt, you produce a record. So transactions, as we are familiar with today, electronic transactions to be specific, electronic transactions that we are familiar with today are simply nothing more than records being created. And when we recognize that, it helps us better understand how cryptocurrency transactions take place. So cryptocurrency transactions actually take place, fairly similar to an electronic transfer. The only difference is the parties involved. Let's say that, Alice wanted to send 1 Bitcoin to Ben. Now, if Alice wanted to send 1 Bitcoin to Ben, and we covered very briefly in the earlier slides that, the Bitcoin blockchain is nothing more than a database that is created, that is storing information over time, right? Every time a new block is stored, inside that block is just a bunch of new transactions that is being recorded. So if Alice wants to send 1 Bitcoin to Ben, the difference is, she doesn't have to go to a bank or any kind of intermediary. Alice, through an Internet Explorer, is able to directly connect to the blockchain. Once she's connected to the blockchain, and as the blockchain is just, periodically storing transaction information, all she needs to do is connect to the blockchain, tell the blockchain, hey, I want to send 1 Bitcoin from my account to Ben. At that point, she would need to verify that she owns the account of which she's trying to send money out from, in which case she needs to provide the blockchain with something called a private key, right? We'll cover this in a little bit more detail later on, but you can think of a private key kind of like a password, right? Or like a PIN number. Just like how if you want to do a bank transfer today, you got to, put in your PIN, you just got to sign off. In a blockchain-based system, there's got to be some kind of, verification means as well. And so we use something called a private key which is treated like a password. So if Alice wants to send 1 Bitcoin to Ben, she connects directly to the blockchain, she proposes that transaction, and she signs it with her password or private key. Now, at that point, rather than having, banks or intermediaries or some kind of organization sitting in the middle that performs the verification, what's unique about the blockchain is the blockchain itself approves and validates the transaction, right? So the blockchain itself is the one that checks, is the password that Alice provided correct? And the blockchain is the one that checks, does Alice have 1 Bitcoin to send to Ben? Now, how does the blockchain know how much money Alice has? Well, just like how does the bank know how much money I have inside the bank? Well, the bank has access to my entire transaction history. They know how much I've deposited, how much I've withdrawn, so they know how much I have inside the bank. Blockchain works exactly the same. Because the Bitcoin blockchain is a record of every single Bitcoin transaction that has ever happened, it knows how much Bitcoin is sitting in every single account. And so it's able to verify that, hey, Alice does have that 1 Bitcoin that she's trying to send to Ben. So if the network, observes the transactions, verifies that Alice's password or private key is correct, she does have, sufficient balance inside her account to initiate this transaction. At that point, the network will automatically approve, validate the transaction, and when the blockchain creates the next block, information about Alice's transaction to Ben will be included inside that block and added to the blockchain. And again, this is important. It is only when the transaction is added to the blockchain that a transparent and immutable record of that transaction is created. And it's only when that record of that transaction is created can Ben then say that he's received 1 Bitcoin from Alice, right? So in both your Web 2 based system and your Web 3 based system, it's actually pretty similar. Whether or not a transaction takes place depends on whether or not a record of that transaction has taken place. The difference between the two is in a Web 2 based system, you have a bank that's recording this information. You have a bank that is validating this information. In a Web 3 based system, you have no intermediary sitting in the middle. It's a computer program that is validating the information, and it's a distributed based ledger system that is recording this information. Right? And I bring this up because just like how, if you were conducting a traditional tracing exercise where, your threat actor had performed money laundering via fiat through banks, what would you normally do? You would call up all the corresponding banks in order to get the necessary transaction information for you to perform your tracing exercise. The difference with Web3 investigations and tracing is you don't have to call up anyone to get access to this information because like what we talked about early on, blockchains are distributed ledgers that store information in a distributed and transparent manner, which means when we conduct crypto investigations, we actually have many, many, many different avenues in order to get access to the information that we want. Every node operator, right, is potentially a source of transaction information that you can use to conduct your tracing exercise. And a lot of companies who run their own nodes have then built services that allows other people to access the blockchain data through their platforms, right? Blockchain analytic providers are one, but like I mentioned, there are also companies who offer this solution for free, and I will cover a couple of them in today's session as well. But with that said, I want to pause here for a second to see if anybody has any questions about what I just covered, the difference between, let's say, a electronic transaction versus a crypto transaction. All right. If there are no further questions, then we will proceed forward. So the next thing I want to do is actually show you guys what a cryptocurrency transaction looks like, so we can start getting an idea of what information we have available for tracing. But before I do that, I want to dispel one myth, right? a lot of the early literature around cryptocurrency and blockchains, this was still when Bitcoin first came about, was that Bitcoin and blockchain or cryptocurrencies are anonymous, right? It's untraceable. And there's a lot of literature about this, which actually led to a lot of criminals in the early days, jumping onto the technology and utilizing it as a means for payment because they assumed that this was something that couldn't be traced. Unfortunately for them, this is not true. Right. Cryptocurrency and blockchain, strictly speaking, are not anonymous. They are, in fact, what we call pseudonymous. And there is a clear distinction between the two. When we say something is anonymous, we're really saying that we don't know anything about the person or individual or organization behind it. Right? We know nothing about it. But when we say something is pseudonymous, we are saying that, okay, even though we may not know who is behind it, we do have, certain data points that can help us identify if the same individual is performing an activity. To give you a very good example, for those of you who play online games, right? When you create a new character and you are allowed to give your character a name, you can give it any name that you want, right? You can call it Pikachu, for example, right? That would be an example of something that's pseudonymous. Although people would not know who controls Pikachu, they can see what the character does and they can associate, activity and behavior to that character. So Pikachu itself, that name is a pseudonymous name, right? Now, in cryptocurrencies, why we say cryptocurrencies are pseudonymous is because although we may not know who has performed a transaction, whenever a cryptocurrency transaction is performed, we can see the wallet ID, or the address, as we use in crypto, we can see the address that have performed the transaction, right? So this is an example of a Bitcoin transaction, and this is a screenshot taken from a free tool available online that allows people to search the Bitcoin blockchain. So very briefly, let me kind of cover what it is that we're looking at over here. So whenever a cryptocurrency transaction takes place, a cryptocurrency hash is generated. Now, you can think of a cryptocurrency hash as a transaction ID, right? This is a unique identifier that points to a unique transaction. So if you wanted to reference a specific transaction for a case, you could just simply provide the transaction hash. Alongside the transaction hash, what is also usually provided then is the fee, right? So a lot of people in the past say, cryptocurrency transactions are free or very cheap. Well, they're not free. There's usually always a fee involved, but this fee can be relatively low, right? That being said, I do want to highlight that the fee paid is really up to the sender, right? Which means the sender can choose to pay $1, $1,000, $1 million. And there have been instances in the past where the sender accidentally, keys in the wrong number and pays a fee of over $1 million, right? Now, there is significance on the fee, but we'll come to that later on from a analytical perspective. Taking a look at the fee amount sometimes can provide you some insight as to the purpose of a transaction. But you are absolutely correct. James, the person who mined that $1 million was a very happy guy. Although, fun fact, the organization that received that $1 million, I do believe that as a gesture of goodwill, they returned half. Not all, half, which is still better than nothing, I'd say. Now, aside from the fee, we then also typically have what's called the block ID, right? So like I say, blockchain stores information in metaphorical blocks, and there is actually a block number associated with each block. So you could get a block ID, you would get what's called the block time, right? So when this transaction took place. But one of the most important information would be at the bottom over here, where you would get the sender address, right? So this is the account ID of the sender. You would get the receiver address. So this is the address ID of the receiver. And then, of course, very importantly, you would get the sending amount and the receiving amount. And there are oftentimes a discrepancy between the two. Oftentimes, this is simply because of the fee, but it is possible that there's discrepancy for other reasons as well. So this is an example of a Bitcoin transaction. And just very quickly, I want to also show you guys an example of an Ethereum transaction, right? Bitcoin and Ethereum are by far, one of the two most popular cryptocurrency and blockchains in existence today. So oftentimes, it's more than likely that you will encounter one of these two in cases, right? Now, this is again a screenshot that I've taken from another free blockchain explorer specifically geared for Ethereum. This was taken from Etherscan, but similarly, you can see we can also find the same transaction hash, block time, timestamp. We have the sender, right? So this is the sender address ID. We have the receiver address ID, the value, how much was sent, the fee that was paid, and so on. Okay. So if you think about it, cryptocurrency transactions are not too dissimilar from, let's say, a bank transaction, where in a bank transaction, similarly, you would have the sender account, the receiver account, the timestamp, the amount sent, and so on and so forth, right? So to be completely honest, when we're thinking of conducting, cryptocurrency tracing exercises, really just, following the money. And a lot of the same principles that can be applied in traditional fiat tracing could also be applied to crypto with certain, caveats, of course. But a basic approach and starting point is similar, right? You are looking at transaction information in order to follow the money. Now, what is the objective of crypto tracing then? Right. So whenever we're conducting a crypto tracing exercise, it's always very important for us to focus on what are we trying to find out, right? What is the ultimate goal of the investigation in question, right? Because through blockchain analysis, we have access to a lot of information, right? We can find out, where are the funds coming from? Where are the funds going? We're able to see all the different businesses that a user had interacted with, both good or bad. It's also possible as to, through blockchain analysis, identify other accounts which are controlled by the same threat actor, right? We can see, potentially where they are cashing out their funds, because as much as crypto and blockchain is becoming more and more mainstream today, oftentimes these criminals still need to convert their crypto to fiat in order to take care of day-to-day expenses and so on and so forth. And then finally, ideally, we're also able to get information that can help us de-anonymize the threat actor behind an incident, right? So all that being said, in my experience, usually an investigator is trying to find out one of two things, right? If they are fortunate enough to have an incident reported to them in time and they are able to, conduct tracing in real time, they might be able to then identify where the stolen assets are being moved to, with the goal of course, contacting the recipient entity, freezing the funds, and then having it seized, right? The reality of the fact, though, is unfortunately, by the time most cases are reported, funds have already moved out. And so the next best thing that an investigator is trying to do is, can we identify the threat actor behind the incident, right? Be it an individual or organization, where we can pursue other legal actions against them in a personal capacity. Now, because crypto and blockchain is not anonymous but pseudonymous, all we can actually see through blockchain data is the addresses or the account IDs of where these funds are coming and going. And so the only way, or the most effective way for us to de-anonymize an account and tie a name or an entity to the wallet, is by tracing funds from these accounts to hopefully a VAS, right, a virtual asset service provider, ideally one, in a regulated jurisdiction, who will respond to requests, who've also conducted strict KYC checks on their clients, right? In instances like this, if we are lucky, we are then able to submit a formal request to one of these VAS, who can then take a look at the KYC information they have on their user, provide that to law enforcement, which then allows us to put a name to an account, right? So this is usually what we're trying to achieve with crypto tracing and investigations. Now, where can we get access to this information then? Like I mentioned, today, with a lot of these blockchains out there, there are many people who are operating nodes, right? Again, a node being storing a full copy of the blockchain. And a lot of these organizations who run these nodes may make this information available either at cost or for free. And some of these organizations who have made this available for free operate what we call a blockchain explorer. So what is a blockchain explorer? A blockchain explorer is basically a publicly accessible online platform that allows individuals like you and me to explore blockchain transactions for free, right? It provides a very user-friendly interface. Although I actually think that previous versions of it were better. I actually think some of the newer versions are less user-friendly. But irrespective, what users can do with these blockchain explorers is you can search up specific transactions, addresses, in order to retrieve the information that I showed you previously, right? Things like sender, receiver, transaction amount, timestamp, transaction volumes, and so on and so forth. Now, there are many different blockchain explorers out there, and typically, most blockchain explorers would just focus on one blockchain, right? So to give you guys some examples, some of the more popular blockchain explorers would be things like blockchain.com, right? This is one of the most popular Bitcoin explorers out there. It's been around for a very, very long time. And so the way that you would use an explorer is all you need to do is put in a cryptocurrency address or transaction hash. And what the explorer actually does is it runs a search through the entire Bitcoin node, and it pulls up all the information about this address and consolidates it for you, right? So when I search up this Bitcoin address, Explorer is telling me, okay, we found one blockchain with a result to your search. I click on it, and voila. Now they're providing me aggregated information about this Bitcoin address, right? They're telling me how much this address has received, how many transactions it's done. They're telling me how much was sent, how much was processed in totality. If I scroll down, I can see all the different transactions that this address had done, right? So transaction number 1, senders to receivers. Transaction number 2, senders to receivers. Transactions number 3, senders and receivers, right? So every single transaction history of a cryptocurrency wallet is actually freely available for anyone with an internet connection to review, right? Now, this is for Bitcoin, but like I said, there's many different explorers out there. So the most popular one for Ethereum is then something called Etherscan. And the UI, of the different explorers sometimes can differ a little bit, but the starting point is usually the same. All you need to do is put in a cryptocurrency address, a cryptocurrency transaction hash, press enter, and these explorers will again run a search through the entire blockchain and pull up information for you. So if this address, again, they're giving me the balance, they're giving me, the last transaction, the first transaction. And if I scroll down, I can now see every single transaction that this address has conducted, who they received it from, and who they sent it to. Now, I'll show you one final explorer for the sake of this workshop, which is Transcan, right? So again, similar explorer, but this is for the Tron blockchain. And the starting point, again, all we need to do is put in an address, Tron address, press enter, run a search, and voila, it'll pull up, the address information, and so on and so forth. Now, why are explorers important? As I covered in the earlier section, every blockchain is a new database, right? The Bitcoin blockchain has more than 10,000 nodes in existence. The Ethereum blockchain also has a couple of thousand, and other blockchains have different number of nodes, but all blockchains are independent databases, right? And the challenge that comes with all these independent databases is that if you are conducting an investigation and you need access to those databases, you need to know where to go. Now, most blockchain analytic providers, thankfully, would usually provide coverage for multiple blockchains, right? Merkle Science, for example, today we have coverage for about 18 plus blockchains, a couple thousand tokens on top of it. Which may seem like a lot, but it's actually not, right? Today, there are easily hundreds of blockchains out there, and there are easily tens, if not hundreds of thousands of different tokens out there. And it is absolutely impossible for you to expect blockchain analytic firms to have coverage for all blockchains. And the reason I point that out is because criminals today are becoming more and more savvy in terms of understanding the limitations from law enforcement. They recognize that, law enforcement today have access to, all these different tools, but these tools may not have coverage for all the different blockchains. So what do some of these criminals do today? Once they've stolen their funds on, let's say, a Bitcoin blockchain or an Ethereum blockchain, they then try very hard to move those funds from one of the more popular blockchains to one of the lesser popular blockchains, right? With the goal of course, making it more difficult for law enforcement to continue the tracing, because if it moves from one blockchain to another blockchain, which their tool doesn't have coverage for, in their minds, tracing ends there, right? Why I'm introducing the concept of explorers to you guys is, for a lot of the newer blockchains, even though a blockchain analytic provider may not have provided support for those blockchains, more often than not, those blockchains would have their own blockchain explorer out there online. And the reason for them wanting to launch their own block explorer is because, as you can imagine, from a business perspective, these blockchains want to get more people and businesses interacting with them. So they actually have to make this information available for their community, which means that when you are conducting a trace, and if you're using a tool and you see funds going into a blockchain which your tool does not support, it's not the end of the world. Feel free to just, go online, look up a Google search. Let's say, funds have moved on to EN blockchain, just run a quick search, EN blockchain explorer, right? Chances are you will be directed to an explorer that will look something similar to this, that will allow you to do basic tracing still, okay? So that's one of the reasons why I wanted to point out the importance of explorers. The other thing about explorers is not all the time, but in certain instances, some explorers may also have more information than certain blockchain analytical tools, right? And so there is sometimes value of still using Explorer even though you have a tool. And in fact, a lot of the more sophisticated investigators that I know of would oftentimes use an Explorer in parallel with one or more tools, because the more information about the transaction that you have, the better equipped you are for an analysis, right? Now, although explorers are great though, there are, of course, certain limitations, right? Some of the key limitations include, like I said, crypto and blockchain is pseudonymous in nature, and by and large, although blockchain explorers will provide you transaction information, where did the funds go? They may not reveal any attribution, right? Which means they may not be able to tell you, okay, this is a Coinbase address or a Binance address, this is a hacker address, or this is that address, right? So there is a lack of blockchain intelligence, not just from an attribution perspective, but a lot of these explorers also don't do what we call clustering, right? And I will elaborate on this a little bit more, but A cluster is basically a group of addresses which are controlled by the same individual, right? Well, most of these blockchain explorers also lack proper visualization tools, right? As well as they only give you, snapshots of information rather than providing you the entire trail in an easily viewable manner. Now, not all explorers are created equal, right? So although most explorers don't provide any kind of attribution information, I do want to point out that Etherscan, being one of the oldest and most mature explorers out there, they do actually provide some kind of attribution, right? Which means when you're looking up addresses, in this case, this address, they do actually tell me at the top over here that it has a public name tag called bitget5, right? Bitget is actually the name of an exchange. So what they're saying over here is that, hey, we've identified multiple Bitget addresses. And so we've assigned this number 5. Now, I want to bring this up because if you're using a tool and the tool is unable to give you any attribution at all, then you may want to see if you can find anything online. The difficulty of relying on attribution from sources like explorers is oftentimes these block explorers may not have done any kind of verification behind the attribution. As you can see, this is called public name tag, and they actually allow users to submit tags to them, which they may or may not verify before they add it in, right? And so what this means is that if you are relying on the attribution that you obtain from an explorer, you may encounter difficulties later on when you get questions about the reliability of the source, right? Because a lot of these explorers may not even be able to provide you with source documentation. That being said, again, if you don't have any other attribution to rely on, this could still provide a good starting point, because even if you may not be able to rely on this source directly, you could, for example, submit a request to Bitget to get them to confirm that this is an address in their control, in which case you would then be able to use that information. So I know I've been covering through a lot of content so far. Again, I just want to maybe pause here for about 10, 15 seconds to give people an opportunity to digest and see if there's any questions that anybody has. All right. If not, then we'll continue on. All right. I just have one more section to cover before we turn it over to our guest speaker, Matt Swenson, and I will address those questions in a second as well. But the last topic that I want to cover before we move on to the Q&A with Matt is with regards to wallets, right? So we talked a lot about, what is crypto, what is blockchain, but, from an investigator's perspective, we also need to be very conscious about how are these cryptocurrencies stored, right? So what is a wallet? When we think about a wallet, in the context of crypto, a wallet is simply an application that functions as a digital wallet for your cryptocurrency, right? What it means is that these wallets are simply software that store the private key, right? So this term that I mentioned previously, the private key, which you can think about like a password, which you use to sign your cryptocurrency transactions, right? I cannot emphasize this importance enough. The private key of a wallet is the single most important piece of information for a cryptocurrency user, right? If you have your private key compromised, anybody with access to a user's private key is able to access their cryptocurrency, right? I repeat, anybody with access to the private key to a cryptocurrency wallet is able to access and transact all the cryptocurrency inside it. Now, to be a little bit more specific, a private key is a code that is provided to you that is unique, that a user uses to access their cryptocurrency wallet. Now, how is a private key generated and things like that? That's a little bit too technical, which again, we won't cover in today's course. All you really need to really take away is a private key is a unique password that a user uses to access their cryptocurrency wallet, right? And the way that these private keys can be generated, there's a couple of different ways, but one of the most common way for these private keys to be generated is through something called a seed phrase, which looks a lot like what you see in this image over here. A seed phrase is basically, not 12 to 16 to 24 characters, words, short words, which can be used to regenerate the private key. I repeat, the seed phrase is just a series of words which can be used to regenerate the private key. So what that means is, with the seed phrase, you can obtain the private key. What that means is the seed phrase is just as important as the private key. If somebody has your seed phrase, you can treat it as though they have your private key. Why do I bring this up? Is because in a lot of in investigation cases, sometimes when it comes to actually apprehending the criminal, or sometimes when you're at the site of an incident and you're looking around, there have been instances in the past where people seize a private key and they don't recognize it, right? Or they seize a piece of paper with a bunch of short words on it and they have no idea what it means. Well, again, I want to highlight a seed phrase is a bunch of short character words which can be used to generate the private key. So if you ever apprehend somebody and you're searching through them, you find a piece of paper with a bunch of weird words on it, don't throw it away, right? It's not a shopping list. It's not a random list. It could be a list of words that leads you to the threat actor's account private key that unlocks his funds. Okay. So I just want to point that out real quick. Now, again, this is something that you don't really need to understand the technicals about it, but the private key, public key, and the Bitcoin address has a very unique relationship between the three. With the private key, we can generate the public key, which allows us to generate the Bitcoin address. Again, you don't really need to understand, the technicalities behind it. All you need to know is the private key is the password, and the Bitcoin address is the unique identifier or the account ID that people usually share around. So if you wanted to receive payment in crypto, you would share your Bitcoin address to an individual, and that individual would be able to transact funds to your Bitcoin address. So it's very much like a bank account number, right? If you wanted to receive money, you would send your bank account number, and they would be able to send you funds accordingly. And then finally, when we talk about wallets, I also want to draw a distinction between what we call hosted wallets and unhosted wallets, right? So in order for somebody to access their cryptocurrency account, they need to be able to have the private key. That being said, a lot of exchanges today, for example, Binance, Coinbase being prime examples, the way that they operate is, although they allow users to create an account on their exchange and they assign a cryptocurrency wallet to that user, Binance or Coinbase is actually the one that controls the private key of all their users' accounts, right? So even though I create an account in Binance and Binance gives me a wallet to deposit funds in, that wallet, strictly speaking, is called a hosted wallet because the private key of that wallet is controlled by Binance, right? And so this is what we call hosted wallets. Wallets where the private key is controlled by a third party. I highlight this because there's a distinction between this and what we then call unhosted or private wallets, which means wallets where the private key is actually in control by the user. Good examples of private wallets would be things like MetaMask, right? A browser-based wallet which you can create on your browser, or things like a Trezor wallet, which is a hardware wallet. I bring this up because very importantly, when it comes to seizing, it's important to know if a wallet is hosted or not, because if the wallet that is holding the misappropriated asset is hosted, you need to identify who is the host, and you will be sending a request to that host to unlock the funds, right? Whereas if a wallet is, a private wallet, then it becomes a little bit more challenging because you actually have to identify the specific individual who controls the private key to get him to unlock the funds. And then from there, I touched upon, what a hardware wallet is and what a software wallet is. So hardware wallet, as you can imagine, the term hardware means a physical device. So if a private key is what's used to unlock an individual's cryptocurrency wallet or address, question becomes, how do we store these private keys, right? So again, two most common ways is through either a hardware wallet or software wallet. In a hardware wallet, it's something like the treasure that you see over here, right? This is a Ledger wallet. It's one of the most popular hardware wallets out there. It kind of looks like a thumb drive, right? Which you stick it into your PC, and a hardware wallet is what stores the private key. So when you connect this to your PC, it actually shares the private key of your computer and unlocks your funds, right? This is by far a more secure way of storing your funds, because unless the hardware wallet gets compromised, there's no way for somebody to access it. And this is, of course, in contrast to like a software wallet, like a MetaMask, where it's an online application that stores your private key. And so if your device gets compromised or something, it is more susceptible to attacks and theft. So that's everything that I wanted to cover from a wallet side of things. And just to kind of round up all the different terminologies before we kick things off with the Q&A with Matt. So right from the basics, we talked about what is a blockchain. Blockchain is simply a way of storing and sharing information, right, in a distributed manner. So rather than having all the information in one location, right, we're building a decentralized and connected database of multiple parties all connecting and storing the information. What is a cryptocurrency? Well, a cryptocurrency is just a digital asset that is issued and transacted on the blockchain, right? So every time a cryptocurrency transaction takes place, a record is created, which is stored inside the blockchain. Talk about what is a wallet. A wallet is simply an application users use to manage their private key. This could be a hardware wallet, which is a physical device, or software wallet. We talked about an address or public key, right? This is where your cryptocurrency is stored, right? It's what you would typically share with somebody if you were looking to receive crypto. There's a private key. Private key is simply the access key or a password required to transact cryptocurrency, right? It's what allows you to unlock your funds. We talked briefly about a seed phrase, right, which is a series of words used to generate a private key. A transaction hash, a unique identifier generated with references a specific transaction. So basically the transaction ID, the transaction fee, right, the amount paid to perform a cryptocurrency transactions. We didn't actually touch on this so much yet, but we'll cover it a little bit more detail later on. Hops, right? So when we talk about hops, we're really talking about distance from one address to another. So address A send funds to address B. We say address A is one hop from address B. And then finally, the concept of a node, right? Which is a device that simply stores an entire copy of that specific blockchain, right? So with this, we've come to the end of the first part of the workshop, right? And with that, I actually would like to invite my colleague and friend, Matt Swenson, who's kindly dialed in to join us for this next section, which is a short Q&A, which allows us to tap onto, his expertise and experience. So without further ado, Matt, why don't I invite you to just maybe do a short introduction about yourself first, and then we can dive straight into it.
Sure. Thanks, Ian. Thanks for having me. I was a special agent with HSI, Homeland Security Investigations, for 20 years. I retired in October of 2022 out of the Cybercrime Center in Fairfax, Virginia. I was the division chief for the cyber division for HSI. Previous to that, I was the unit chief over the cybercrime unit specifically, which had oversight into all things dark web, cryptocurrency, cyber threat intelligence, network intrusion investigations, all that type of stuff, cyber related. And so we had a lot of cases that we were working with the cyber nexus that specifically pertained to blockchain and cryptocurrencies. And now I'm currently the CEO of North America for the software company Black Rainbow. And again, thanks for having me.
Awesome. Thank you so much for the introduction, Matt. So as you guys have heard from Matt himself, he has a wealth of experience and he's very kindly offered us, 30 minutes of his time to answer any questions that we might have. So prior to, the session itself, we did have some individuals who had written in with some questions already. So I will kick things off with a couple of these questions, but, for those of you in the call, if you have any questions, this is your opportunity to post it inside the Q&A section, and we will circle around to it, right? But with that said, let's kick things off with some of these questions that have come in earlier. So question number one, Matt, what are some of the considerations for law enforcement that you can share, when conducting an investigation that might have a nexus to cryptocurrencies?
Sure. So one of the things that we did at HSI was that we did a lot of training to state and local agencies in particular, where we would send people around the United States to train state and locals, because we kind of viewed the state and local investigators and officers as the front lines, or really the eyes and ears in a lot of these investigations. And a lot of time we as feds kind of don't have that frontline visibility into things. We have an overview kind of at a national level, at a federal level of things, but being down on the streets and actually seeing the immediate impact of illicit activity, of cryptocurrency and the dark web in particular, I think allows you to kind of see the end of the chain in a lot of these transactions. And so what we would do, because we tend to have a very holistic type look, or a very top level, I should say, look on these investigations, but not necessarily a bottom level, was to go in and try and work with state and locals to say, hey, are you seeing any of these cases? And if you're not, here's some of the things that you might want to look for. So like that terminology sheet that you had, Ian, is a perfect example. So it's first being able to identify the artifacts and those types of information, tidbits that will realize like, hey, this is indicative of a case involving cryptocurrency. So for example, if you were a state and local officer and you came across a fentanyl overdose, when I was in Los Angeles, in the Los Angeles field office, we would work a lot with LAPD, and we would come across fentanyl overdoses where at face value, it may look like, hey, this person just bought some tainted drugs, or they bought some fentanyl off the street and they overdosed, and you write it up as an overdose and you're gone. But that may not necessarily be the case. If you were to go process that same evidence, look at the mobile device, look at their laptop, and see things indicative of stuff on your terminology sheet, and where it shows like, hey, they used a mobile wallet to store cryptocurrencies, or I found a seed phrase on a note document on their desktop of their computer, you may say, oh, well, maybe this wasn't just a street deal. Maybe they're actually purchasing this from a dark web vendor using, whatever type of cryptocurrency. So that was kind of the thing. And then once you get there, then what do you do with it? How do you tie that back into a potential larger scale investigation? So things like deconfliction, if you have access to the DEA DICE system, is taking those artifacts. Then if you found a wallet address, if you found something unique that is related to cryptocurrency and you put it in the DICE system, there's a very good likelihood that it's going to ping into another agency's case, whether it be HSI, FBI, DEA, Secret Service, Postal, whoever, or another state and local agency. That's a good place to check and see, hey, does somebody already have an open investigation on this? Is there some other information that I can use to tie this back to a larger investigation? And we ended up being very successful with that, particularly tying fentanyl overdoses back to dark web vendors. And that was almost all done through cryptocurrency analytics. And the good thing is for us as federal investigators, a lot of time those state charges of the overdose with the Len Bias overdose statute incur significantly more or higher penalties of 10, 15 years as opposed to, 3, 4 years for charging the vendor with just a straight narcotics distribution case. So I think the first and foremost most important thing is being able to identify the signs of illicit cryptocurrency use, and then having a plan. I think the second part is having a plan. And if we're going to go in and we're going to do an enforcement activity, let's be ready that we may encounter cryptocurrency. What do we do with it? If we go in and we do a search warrant and we find out that this person has 10, 15 million dollars or even less, a couple $1,000,000 worth of cryptocurrency, what do we do with it? Do we have a policy? Are we ready to handle it? Do we know, where we're going to move it to? So having that, and we had to figure this out as we progressed as an agency. At the very beginning, we worked on the Silk Road investigation, which was really ground zero for illicit cryptocurrency use. It was really one of the largest test cases for using cryptocurrency as a digital currency in a market. Was trying to figure out, okay, I think we seized $2 million, and it was really the first time we had ever made a seizure of that of cryptocurrency before. So we took it from the wallet that we seized and we moved it to a hardware wallet, just like Ian demonstrated, to a Trezor, and then just prayed that, hey, it's actually going to move over there, because we had never done it before. And sure enough, luckily it worked. We typed the addresses in correctly and everything. And we've come a long way since then, but I think there's a lot of agencies that haven't dealt with it before. And you hopefully want to have a plan in place before you're going out there, the first time. And so those types of things, saying, hey, we need to move it to a government controlled wallet. We need to ensure access control, that only a certain amount of people have it. Follow your basic chain of custody requirements, but know, hey, when we go there, if we're going to move it to a Trezor, who has access to it? Who knows how to unlock it? And then what are we going to do with it? We're going to put it in an evidence vault that's controlled, and evidence custodian is going to check it in, and we're going to put it in the system, and we know how much, and all of those types of things. And then understand, how are we going to treat it? Are we going to treat it like a commodity? Are we going to treat it like a currency? When we declare the value, you have to know that cryptocurrency tends to be very volatile. So if you check it in at, hey, we see 75,000, and then 6 months down the road you're going to forfeit it, and now it's only 50,000, or maybe it's 150,000, just be aware that other people within your department or your agency should understand that that's very normal. So I think those types of things really is having a plan, being able to identify it, and then once you encounter it, what do you do after the fact?
No, thank you very much, Matt, for sharing that. No, I couldn't agree more. In many cases that we've engaged with different law enforcement in the past, we hear stories of, they enter the site, they see a bunch of stuff, and they're not sure what to do about it. And in fact, there was even this one case where it was quite interesting. I remember I think somewhere in Europe, an agent had shared that, they had seized a wallet. They had put it through one of the wallets explorers that they had, and they saw that there were no funds inside there, so they assumed there was an empty wallet. But what they didn't know was that if they had put the same address through a different wallet software, which had a little bit more coverage, that wallet actually had $250,000 of some unknown token sitting inside. So, simple things like this, where if the agent at hand had just a little bit more proficiency, will go a long way in making sure that these gaps like this don't happen. So I couldn't agree more. I think having a plan of action is definitely important, and making sure that, again, agents have at least a fundamental understanding of how the technology works. So when they go onto a site, if they access a PC and they see a wallet software online, they immediately know, okay, maybe cryptocurrencies involved, and these are the stuff that we should be looking at. Um, you touched a little bit on what to do thereafter, right? And I think that is definitely a challenge that a lot of agents face, from a seizure perspective, like how to do it correctly. And I do believe there was even an incident in the past where I think one of the agents may have accidentally sent funds to a different address as well. So could you share a little bit more about maybe some tips as to what an agent should do if they do come across cryptocurrency on scene, and some of the warnings that maybe they want to keep at the back of their head as well.
Yeah, and going back to one of your previous slides, I saw, what I think is very important is making sure you have full access to the wallet, making sure you have access to the private keys. Because I've actually seen this actually happened in an investigation where they seized a laptop computer, but they didn't have access. They just assumed that because they were seizing the laptop that all of the public and private keys would be hosted on that laptop, when in fact they were not. And so they seized a wallet worth $10 million and couldn't access it. So, while you're in scene, particularly if the person you're talking to, the suspect, is cooperating, you want to make sure you ask those questions like, hey, what are all your public and private keys? What are all your passwords? What are all your user accounts and whatnot? Because you may only get one chance at it, and then you shut that laptop off, and that may be it. And then now you're trying to proffer that out as part of, a plea agreement or whatever at the end, which is less than ideal. But that goes with just having a plan. I got called at one point because I was the resident digital forensics guy in the Los Angeles area that knew how to identify cryptocurrency from a digital forensics perspective. And I would get called a lot of times very late, when they're doing an enforcement op last minute, doing a controlled delivery or of narcotics or something. And I would show up, and sure enough, I would do my digital forensic analysis on the computer. I would see, sure enough, they have, software, crypto wallets on there. There's money in there and whatnot. And then I'd say, okay, we need to seize this. And then the team that's there is like, well, how do we do that? They haven't even thought about it until you're dealing with it. And that's less than ideal, because now you're scrambling. You're like, hey, do we go buy a hardware wallet? Do we call back to headquarters? If you're on the West Coast, there may not be anybody there because it's after hours. All those types of things you want to have a plan for, preferably beforehand and not while you're there doing it. So I think as much of that you can kind of iron out and figure out and understand, your department or agency's procedures, the better, because you don't want to be left figuring that out, while you're on scene, processing a search warrant or whatever.
No, thank you. That makes a lot of sense. Yeah, one of the unique things I think about crypto cases that I've seen in the past is, when criminals misappropriate assets, they're not in a rush to move it out sometimes, right? I think if the Bitstamp incident, funds were literally sitting in the wallet for I think like 3-4 years, because these criminals were very confident that, hey, as long as nobody have access to our private keys, regardless of where they know the money is sitting, nobody's able to access it. So to be very aware of the importance of private keys, and don't make the assumption of thinking that if you arrest a person and he has access to the keys, that he's the only one with access to the keys, right? There's a good chance that maybe he has a collaborator who also has access to the private keys. So even though you have one guy in custody, if there's someone out there with the private keys, they still have the ability to move the funds out, right? So once you have gain access, first things first, always try to move the funds into a government control wallet as soon as possible, to reduce the odds of somebody else gaining access to the funds first. So with that, I haven't seen any new questions come in. So again, I do want to emphasize again, this is a great opportunity to tap onto Matt's expertise. So if you guys do have any questions, please feel free to put them inside the chat. But whilst we wait, there is a couple more that we had that had come in earlier on. So we can maybe jump to the next one. Matt, could you share a little bit more about what the process looks like for federal agencies, and what should these local law enforcement officers do when they encounter cases? What type of cases, should they feel comfortable in be dealing on their own, and when should they maybe consider escalating up to a federal level for assistance?
Yeah, so I think that the tie-in there is when you get an investigation that there's a good portion of that outside of what your normal jurisdiction would be. So, back to the fentanyl example, say you're investigating an overdose death, but say the vendor that sold the package is in the Netherlands or, in New York or somewhere else. It's going to be extremely difficult with your resources within your kind of area of responsibility to kind of bridge the gap and tie it into everything else, because that chances are if that vendor shipped a package into your jurisdiction where you have one overdose, there's probably a bunch other packages throughout the world potentially. And I think you'll get a fuller picture if you bring federal assistance in there. In addition to, a lot of time there's a lot of additional resources. So, from the analysis perspective, from the big data perspective, from the attribution perspective, there's probably, or a good chance that there's a lot of other work that's been done on that investigation. And so I think it just kind of brings it all together. Additionally, in terms of prosecution, adopting the case federally can a lot of time bring greater sentences. So, if you're looking at somebody and you're like, hey, if we prosecute this at the state level, although the federal system can be very cumbersome, and that's a whole nother conversation, at the end of it, there's generally greater sentences for the vast majority of the crypto related offenses out there. So that's another reason too, is that, hey, if you want to kind of get the most bang for your buck on the prosecution side, a lot of times adopting these cases makes a lot of sense. So I would say that just kind of having the fuller picture a lot of times, and really tying it into maybe the greater criminal enterprise. And then, a lot of federal agencies have agents and attaché offices overseas, which enables us to work with international partners, because very few of these cases stay domestic anymore. Almost every crypto and cyber case that I was working at the end had an international nexus to it. And so if you really want to work a case and really understand the breadth of it, it's very difficult to do unless you reach out to international partners.
Makes sense. I think that echoes what we've seen more recently. I think crypto being border in nature. Most cryptocurrencies tend to flow back and forth between jurisdictions, probably to make it harder for law enforcement to track, because they recognize the difficulty in cross jurisdiction collaboration. We did have a question that has come in, right? So let me read it out loud for the benefit of everyone. At the local level, we don't get the resources or training on crypto investigations. We do have good relationship with some feds, but we don't have a good model to follow. Could you recommend or name a local agency that has a good crypto working model?
Yeah, I would say the agencies that deal with the highest volume of crypto generally kind of have it worked out the best, and it's usually HSI, FBI, IRS, and Secret Service, I think, are the agencies that I worked with that really dealt with a large volume of cryptocurrency, and they all did things, particularly HSI, IRS, and Secret Service, because they're all legacy Treasury agencies and they deal with Treasury forfeiture. They're all set up fairly similar in the way they do things, and the way we would do things are that toward the end, we would move the crypto to a government-controlled hardware device like a Trezor, or on a government-controlled laptop that had limited access to it. That was actually, you'd have to follow instructions by our asset forfeiture division, and then per the proceedings, when that currency would get forfeited, we would work with the U.S. Marshals. So the U.S. Marshals they have a contract, or at least at the time, they had a contract with Coinbase, and they would just move the currency from whatever cryptocurrency it was into US dollars, so into fiat, and then that's what would go to treasury forfeiture. Is that whatever the market rate was at the point of liquidation, they would liquidate it into US dollars and then move it to treasury forfeiture. So that was the other thing too, is that we would seize cryptocurrencies that weren't accepted by Coinbase or or the marshals didn't have an agreement with. So Monero is a big one, because at the time, and I don't know if this has changed, but Coinbase wouldn't accept Monero. They wouldn't buy or sell Monero. So we would be stuck essentially with tons of Monero that would just basically be in limbo. It would basically be in our evidence system, that we were unable to liquidate. So it's good to know as well, like if you're at a state and local agency and you're developing your own asset forfeiture policy, to ensure that, my recommendation would be to ensure that you have the widest coverage of as many cryptocurrencies that you can liquidate into fiat as humanly possible. Because you just never know these days. You know, the days are gone where we would go in and we would just see Bitcoin. We're seeing a wide variety now. And, you know, you want to be able to forfeit that off.
Awesome. Thank you, Matt. And I want to thank James as well. I think there's also been a suggestion inside the Q&A that if anybody's looking for assistance when it comes to, crypto investigation, there is an email that has been shared inside the Q&A, a law enforcement crypto group which exchanges information and policy. So do feel free to write in. I'm going to trust James that the email is legitimate, given that this is only available to law enforcement. So appreciate you sharing that. Before we kind of end off on the Q&A, and thereafter we will take a 5 to 10 minute break, for people to use the washroom. Is there any final questions for Matthew while we still have him? And whilst we're waiting to see if there are any final questions, Matthew, from your side, before we let you go, and again, thank you so much for taking the time to share your experience and expertise. But do you have any parting tips or advice for members of the audience, given that it sounds like a lot of them are just starting out in their crypto investigation journey?
Yeah, no, I would say, I think, Ian, we talked about this a little bit yesterday, is you have the slides coming up on VASPs. I would encourage people to pay particular attention to that, because a lot of times that'll be your first step in working one of these investigations. Is you'll send some sort of legal paperwork, whether it be a court order or subpoena or whatever, to an exchange for information, and ask for as much information as you possibly can. And some of that information that you get back will be unique to that particular VASP, and it could be some really good identifying information, whether it be what devices they're using, their unique username that'll tie back to additional accounts, all of that type of stuff. I think is going to be extremely beneficial to your investigation. So definitely take a look at that slide and ask Ian any questions on that. I think that'll be very beneficial for everybody.
Awesome. Well, thank you so much for your time, Matt. Really appreciate you dialing in. I know you have a busy schedule. So if anybody else has any further questions for Matthew that we weren't able to address in today's call, feel free to reach out to me, and I'm more than happy to connect you to him directly. Yeah. But with that, really appreciate your time, Matt. Yeah.
No, thanks everybody.
All right. So thank you everybody for staying with us. We've gone for about an hour and a half. So what I typically like to do at this stage is to just take a 10-minute break. Pretty sure some of you might need to get some coffee, use the restroom, get a smoke. So we'll pause here for about 10 minutes. I will have a timer on screen just to kind of keep us on track. But if any of you need to use the washroom and grab coffee, please use this time to do so. I will be hanging around as well. So if anybody has further questions, feel free to post them inside the chat, and I'm happy to address them once we resume. All right, 3, 2, 1, and break is over. So, thank you everybody for your patience. Hopefully, those of you who've needed to use the washroom, get some coffee, have done so. Thank you those of you who have, put in a question during the break. I have addressed most of them. Please do keep the questions coming. Special thanks to James and Nazar for keeping this more interactive. As much as I love speaking and hear my own voice, it's always good to know. It's always good to have some back and forth. So really appreciate you guys responding to my questions. With that said, let's go ahead and proceed with the second half of today's workshop. So in this next session, I want to introduce everybody to this concept called clustering. And this is a very, very important concept when it comes to the crypto investigations and tracing. So let's start off with what is a cluster? Well, clustering or creating a cluster refers to the process of us grouping together blockchain addresses which are likely controlled by the same entity or individual. Now, why is this useful? Well, if I were looking to conduct an investigation and my goal was to identify who controls a wallet or an address, then knowing that there are 10, 15, 50 people to me as an investigator, because what that means is that I can expand my service area to all 50 of those addresses controlled by the same person. And if any of them has any insight as to who controls it, I would then be able to de-anonymize the group of wallets or the cluster of wallets successfully. Now, this exercise of clustering can be done in many different ways. There's clustering through algorithms, there's clustering through certain patterns, as well as there are clustering just through certain characteristics based on addresses. And in today's session, I will just be covering 1 or 2 examples of how clustering is done, so everybody kind of has an idea of what it entails. So the most common clustering methodology used in cryptocurrency today is a clustering method called co-spend, right, or common spend heuristic. And this is a clustering method that is not applicable to all types of cryptocurrencies, but specifically only available to blockchains which adopt something called a UTXO model, an unspent transaction output model. Now, no need for us to go into detail about what that means. Suffice to say that this is a model that's only adopted by blockchains like Bitcoin, Bitcoin Cash, Litecoin, and a few others. But one of the key characteristics of blockchains with a UTXO model is just like what you can see in this image on the right. This is an image of a transaction. And inside this transaction, we have many addresses on the sender side, sending funds to many addresses on the receiver side. Now, I want to emphasize what you're seeing here is an example of a single transaction, which means that in this one transaction, funds were aggregated across all these different addresses and then divided and sent to all these addresses on the right. Now, if we think about this conceptually, if all of these funds were aggregated and consolidated and redistributed to all these addresses on the right in a single transaction, and this is key, all of this was done in a single transaction. For an individual or an organization to consolidate the funds across all these addresses on the left, on the input side, as we call it, right? I repeat, for an individual or organization to consolidate all the funds across all these addresses on the input side and redistribute it to all these addresses on the output side, conceptually, all the addresses on the left, on the input, must be controlled by the same person, right? Because if you remember, how does a cryptocurrency transaction take place? Well, the user proposes a transaction to the blockchain, and he has to provide the private key to unlock the funds in every single wallet that he wants to utilize. So if a user wants to unlock the funds in all these addresses on the input side, that means that he must have the private key to all the addresses on the input side,
thereby by extension, we can say all these addresses are probably controlled by the same person, right? Now, I want to draw a distinction between control and ownership, right? When we talk about ownership, we talk about who is the legal owner. But when we talk about control in the context of cryptocurrency and blockchain, we're really talking about who has control of the private key, right? Because only the owner of the private key can actually move the funds, okay? So this is one example of clustering, and it's the most well-established form of clustering in the industry today. Other forms of clustering could be based on things like custom heuristics, right? So us typically just finding examples of commonalities between cryptocurrency addresses. To give you an example, BitMEX, one of the larger exchanges in existence that's been around for a long time. For those of you who have interacted with BitMEX before, one of the things that you might have noticed is that all BitMEX addresses start with 3BMEX, right? I repeat, all BitMEX addresses start with 3BMEX, which means that if somebody creates an account of BitMEX and they are looking to do a deposit, the address that BitMEX provides them will always start with 3BMEX, right? So this is a business decision taken by BitMEX, right? This is what we call a vanity address, where people create a custom address that they want with certain prefixes. So to the extent that we identify, commonalities like this, we can then group all the addresses that start with B3MEX together and say, okay, all of these are BitMEX's address. Okay. Now, with clustering, it becomes a very powerful tool because with clustering, what that means is if during an investigation, I identify a Bitcoin wallet that is controlled by a criminal, and let's say, this wallet is the one in question, I can actually then go onto the Bitcoin blockchain and look up every single instance of a transaction where this address had its funds aggregated with other addresses and group all those other addresses together and treat it as a cluster, right? So again, a cluster is simply a group of addresses through which it has been identified that they are all controlled by the same individual or organization. Now, clustering is something that blockchain analytic firms do a lot and very commonly, right? So what blockchain analytics,
and we investigate cryptocurrency addresses used by both good actors, right? Your exchanges, your custodians, as well as the bad actors. And whenever we've identified addresses belonging to either, first thing that we will do is put those addresses through all the different clustering algorithms and means that we've developed over time in order to expand our data set. So what that means is that if you give us just one Coinbase address or one Binance address, we can simply, from that address, extrapolate and identify, the millions of addresses controlled by Coinbase or the million addresses controlled by Binance, right? So that is the power of cluster, right? Through one address, we are able to identify a larger group of addresses controlled by the same individual or organization, which then effectively increases our investigation surface area, but also allows us more insight as to how funds are being moved. Now, clustering is also very important from the perspective of attribution, right? Now, in crypto tracing, blockchain data is great in the sense that even if we use open source intelligence platforms like an Explorer, we can identify where funds have gone, right? Funds have moved from wallet A to wallet B to wallet C to wallet D. We can see all of that on the blockchain. The challenge for you as a law enforcement is, well, it's not enough to know that the funds are sitting in wallet A. We actually want to know who controls wallet A, right? And this is where attribution then comes into play. So when we talk about attribution in the context of, crypto and blockchain analytics, we're really talking about, who owns or controls an address or what activity has been associated with that address, right? And like I touched upon briefly, I do want to draw a distinction between ownership and control. Ownership is, who has legal ownership of an asset versus control, right? Who has control of the private key of an address. So usually when you search up an address on different tools, information that you might get back would be things like, okay, we may not know who controls this first address, but we know it's associated with a scam, specifically, a phishing scam. Second address over here, we know through, past experience and investigations that this is an address that's linked to the terrorist group, Al-Qassam Brigades. Or we may simply tell you that, hey, this is an address that we know is associated to Binance, which is an exchange that today collects KYC information on its users, right? So this is typically the type of attribution information that you would expect from a blockchain analytics tool. It's simply either telling you, what is the organization that controls it, or what is the illicit activity that has been identified to be associated with the address. Great. So we talked about, blockchain, we talked about crypto, we talked about transactions, we talked about attribution, right? But the next thing that we then need to talk about is, okay, attribution is great. It's telling you where the funds have gone. But what type of entities are you usually tracing to? And how do these businesses operate, right? So in most of the cases that you guys will be conducting investigations on, again, typically with the goal of identifying where the money has gone or trying to de-anonymize a wallet, you will end up tracing the funds into an exchange, right? Which are vital points of information. So I do want to spend some time talking about how an exchange operates, talk a little bit about how an exchange stores its funds, because there is significance when it comes to tracing. So a cryptocurrency exchange, from a very high level, is basically just a platform for individuals or organizations to go to trade cryptocurrency, right? It's used to buy Bitcoin, sell Bitcoin. It's used to not just trade cryptocurrencies with other form of cryptocurrencies, but exchanges are also typically important on and off ramps, right, for fiat, which means exchanges are typically where individuals or criminals go to convert cash to crypto or sell crypto to cash, right? Exchanges also play a very important role from a regulators and law enforcement perspective because they typically act as the gatekeepers, right? They are like the Web3 banks, right? Today, whenever we want to do a bank transfer, the bank is in charge of doing the KYC checks, the AML checks, the screening, etc. In the Web3 space, the exchanges kind of fulfill the same role, right? They are the regulated entities that are supposed to do KYC, AML checks, and so on. And so if they're doing their job correctly, then as and when law enforcement traces the funds to an exchange, ideally these exchanges would be able to provide accurate information as to who controls the wallet in their exchange. Now, how does an exchange typically operate, and how does it usually store and move its clients' funds throughout the business, right? Now, this is something that is quite important for you as investigators to understand because it will greatly improve your ability to analyze addresses to then get a estimate as to what type of address this is, right? And this will be made a little bit more clear as I go through this slide. So let me walk you guys through typically how an exchange works from the perspective of a user who's just been onboarded and depositing funds into their exchange for the first time. In this example, let's pretend that I'm creating an account on Coinbase. No, sorry, on Binance, right? Now, first thing I do when I create an account on Binance is, I provide Binance with my KYC information, etc. At that point, Binance, verifies it against sanction lists and so on, and Binance approves me as a user, right? Now, the moment I'm approved as a user and Binance creates an account for me, if I want to trade on Binance, I need to fund my account, right? To send money into the account. So Binance would typically assign me a user deposit wallet, right? Which is this wallet that I'm going to circle in blue. Binance will assign me a user deposit wallet, and I will send money into that user deposit wallet from my external wallet, right? Which is this wallet that we see here in red. I'm just gonna put an A next to it, right? So wallet A is my external wallet, right? I create an account in Binance. Binance gives me a user deposit wallet for me to deposit my funds in. Now, once I've deposited my funds into the user deposit wallet, what Binance will typically do at this stage is Binance will take the funds that all its different clients have deposited and consolidate those funds into Binance's hot wallet, right? I repeat, Binance will periodically sweep all of its clients' funds in their deposit wallets into a hot wallet. And from that hot wallet, Binance will then move maybe 90% of its funds into what's called a cold wallet and maintain the other 10% inside the hot wallet. And all withdrawals coming out from Binance, so if I now, let's say, after depositing money into my account, I perform a couple of trades, let's say I was wildly successful, 1 Bitcoin became 10 Bitcoin, and now I want to process a withdrawal. Well, when the user requests a withdrawal of funds, the withdrawal is actually not processed by my user deposit wallet, but it actually comes out of the exchange hot wallet, right? Now, there are many different reasons for an exchange setting up their structure in this manner. Now, if you guys remember, first of all, the difference between a hot and cold wallet. A hot wallet is a wallet where the private key is stored, in an application online, and a cold wallet is usually a hardware wallet that is stored offline. Now, a cold wallet is much more secure. So given that exchanges are oftentimes susceptible to hacks, for compliance, security reasons, and by regulatory requirement, most exchanges today are forced to store most of their funds 90% in cold storage in their cold wallet offline in a more secure manner, right? And that's because most exchanges don't need access to all their clients' funds at any given point of time, right? Most users leave their funds inside the exchange and only process withdrawals occasionally. And so that 10% of their funds sitting inside that hot wallet is usually enough for their day-to-day operations. Now, it's very important that we understand this flow, because when we understand this, it allows us to have certain assumptions about the type of transaction behavior we would expect to see for these different wallets, right? Let me give you an example. Given that the user deposit wallet is simply used to collect funds from clients and then having the funds then sent to the hot wallet, you would imagine that if I'm analyzing a exchange user deposit wallets, I might see many deposits coming in from different places, but all the withdrawals should only go to the same place, right? I repeat, if I'm analyzing a cryptocurrency user deposit wallet, I should expect to see, deposits coming in from maybe different wallets, because a user might be trading on other exchanges, and so there's many different sources of funds coming in. But this wallet should only ever send funds to, the same wallet, which is the exchange hot wallet. Similarly, if I was analyzing the exchange hot wallet, what I would typically expect to see is, thousands, if not millions of deposits coming in from many different wallets, which is every single different exchange client deposit wallet. So if Binance has, 10 million clients, you would expect, 10 million different addresses sending funds into the Binance hot wallet. And similarly, you would expect, withdrawals going out to, tens of thousands, if not tens of millions of different withdrawal wallets as well, right? Because this would be basically processing every single withdrawal of Binance's clients. You would also expect then, if we were analyzing the cold wallet of an exchange, that the cold wallet probably wouldn't have done that many transactions, right? Because typically what the exchange would do is just periodically send big amounts into the hot wallet and vice versa to fund these two wallets. But you would expect a cold wallet to have a very high balance that is maintained over long periods of time and just the occasional transactions with hot wallets. Now, you might struggle to think, why is all this significant right now, right? But don't worry, we will tie the gap later on. Now, with that said, then I just have, a quick test for you guys, right? And I understand that this might be a little bit difficult for you guys to participate given that the chat function does not work. But for those of you who do want to try it out, feel free to just post your answer inside the Q&A. But if I were to ask you guys, based on the information that you see on the slide in front of you, what is your guess as to what type of wallet this is for Binance? Right? So remember, it could be a Binance user deposit wallet, it could be a Binance hot wallet, or it could be a Binance cold wallet. Right? So given the information that you see in front of you, taking into account, the balance, number of deposits, number of withdrawals, how much this address had received, how much this address had sent, would you think that this is hot wallet, a cold wallet, or a user deposit wallet? All right, so I have some answers coming in, right? Interestingly enough, 3 different answers coming in with different responses. So the answer to this is actually a hot wallet, right? And let me explain a little bit why. So number one, if you remember, a hot wallet is used to process is used to consolidate all the user's deposit and used to process all of the exchange's withdrawals. So you would expect, like I mentioned, an abnormally large number of deposits and withdrawals, which corresponds to what we see over here, right? It's very unlikely to be a user deposit wallet because, as you can imagine, it's very unlikely that an individual has performed, 37 million separate deposits into a Binance account. I won't rule out that it's impossible, but it's very unlikely, right? So we can probably rule out user deposit straight up, and then it's really hot and cold wallet. But given the number of deposits and withdrawal, and given that the balance is not that high, I'm leaning, and I know for a fact that this is a hot wallet. If this was a cold wallet, what we would expect is to see, a decent amount of deposits and withdrawals, a high number of receive and send, but we would also expect to see a much larger balance, right? Given that the cold wallet is supposed to be for safekeeping purposes, right? So again, you should expect to see, quite a high balance maintained over time. Let's then contrast this to this next wallet over here. So should be fairly simple, after we analyze the previous one, but what do you guys think this wallet is? So if we look at the number of deposits tree, we look at the number of withdrawals too, very quickly, just looking at these 2 figures, we can already eliminate probably hot and cold wallet. And we're looking more at a user deposit wallet, right? Which all of you have accurately pointed out. The other thing that we can see that would help us say with conviction that this was a user deposit wallet is if we look at the transactions below, there were 2 withdrawals that this address had done, and both withdrawals were to Binance, right? So given that this was a wallet that we've already identified at Binance, and it is also only sending funds into other Binance's wallet, it fits the kind of behavior that we would associate with a Binance user deposit wallet, right? Low number of deposit and withdrawals that correspond to a retail user use case, and the fact that the funds are then being funneled into other Binance's wallet, which is probably their hot wallet for consolidation or safekeeping purposes, right? So very glad that everybody got that. Now, let's then tie this into this next section, mixers, and why it was important for us to understand how exchanges work. So what is a mixer or a tumbler? A mixer or a tumbler is a service that mixes different sources of cryptocurrency, right? It's one of the biggest pain points for law enforcement because it makes it much more difficult for them to conduct tracing. Now, there are many different mixers out there, but the way that most mixers work are pretty similar, right? What happens is, the mixer would ask the user to send funds to a certain predetermined wallet, right? And this could be one wallet or more. And then after the funds have gone in, the provider, the mixer would then ask the user, okay, how would you like me to withdraw your funds? Would you like me to withdraw it to one wallet, many wallets? How would you like the funds to be split across the different wallets? And they could even dictate the time in which they want those funds to arrive. Now, the goal of a mixer is to make it difficult for us to conduct tracing because the goal is to break the trail, right? Obfuscate the source of funds. So to kind of graph it out, how this might look like is, if the user wants to interact with a mixer, the user would deposit the funds into the mixer. The mixer would consolidate the deposit with all the other mixer clients, right? And then from there, the mixer would then redistribute the funds to all its clients, right? So it takes all its clients' monies, it consolidates it, it jumbles it up, and then it redistributes it. And when you think about this flow, it actually reminds us of something very similar, right? Which is exactly how an exchange operates, right? Because an exchange, if you think about it, works the same way. It takes in its funds, from many different clients. It consolidates or it jumbles it together in a hot wallet, and then it redistributes it on the withdrawal side to all its clients, right? Now, the point that I'm trying to make over here is intentional or not, the reality of the fact is most cryptocurrency exchanges and even some businesses knowingly but unintentionally operate as mixers, right? I repeat, because of the way that exchanges operate, unintentionally, all of them kind of operate as mixers because the moment a customer deposits its funds into an exchange, if the exchange doesn't reject the funds and instead allows it to go through its typical workflow like what we see in front of you, what that means is the funds ends up being mixed and consolidated in a hot wallet and redistributed, right? So essentially, it's been laundered, right? So for this and many other reasons, criminals still do end up using exchanges as avenues to launder their funds because the reality is a lot of exchanges have weak security. They don't collect proper KYC information. They have weak KYC and AML controls, or they're based in jurisdictions that are unregulated or not responsive, right? And so criminals do leverage and take advantage of this fact to launder their funds through exchanges in obscure jurisdictions or with weak controls, knowing that the exchange would unintentionally launder their funds simply by moving the funds through. And if these exchanges are in unregulated jurisdiction or with weak AML and KYC controls, then in essence, is essentially acting as a mixer from a law enforcement perspective and tracing perspective. Yeah. So I just wanted to highlight this fact for you, and why I wanted to show you guys examples of what a exchange user deposit wallet looks like and an exchange hot and cold wallet looks like is blockchain analytic tools are not foolproof, right? As much as we spend time and effort developing analysts and intelligence teams, we cannot guarantee that we have attribution for every single business out there, right? If a new exchange were to spin up tomorrow, chances are, Merkle Science or any of the tools out there would not have available attribution data. And one of the biggest mistake that an investigator can make is to trace through a service provider, right? Because like we just discussed, a service provider is essentially a mixer simply by virtue of the way they process clients' deposits and withdrawals. So if you are using a blockchain analytic tool, or you are relying on an open source block explorer to perform your tracing, and you encounter an address that belongs to a service provider that has not been tagged by the tool or has not been tagged by the explorer, I'm hoping that I've provided you enough information to identify that the address is potentially a service provider. Because again, the biggest mistake that you can make is to trace through a service provider. Because if you trace through a service provider and you bring your investigation to any exchange or any court, it will get thrown out, right? Because the fact that you trace through a service provider means that the funds have been mixed, and so anything that you attribute coming out cannot be reliably linked to what was going in, right? So I cannot emphasize this enough. Don't trace through service providers, and don't assume that whatever tool or platform that you use will have accurate and complete attribution, right? There will be gaps in regardless of whatever tool that you use. And so it is important that you have, this understanding of how these businesses operate. So if you are conducting a tracing exercise and you see the funds going into a untagged wallet, and that wallet has done, more than 10 million deposits and 10 million withdrawals, you want to start asking yourself, is this potentially a service provider that may not have been tagged? And hopefully, use the takeaway that you have from this course to kind of evaluate the addresses preceding and after, to then make a more educated guess as to whether it is potentially a service provider. Yeah. All right. With that, we will move on. So next thing I want to talk about very, very briefly is smart contracts, right? Now, smart contracts is something that you guys would probably come across quite often. And it's actually a very complex topic, but I will do my best to give you guys the high-level important facts that you need to know in about 5 minutes, just so you kind of know what is it and kind of how to deal with it, right? So a smart contract is nothing more than a computer program that is stored inside the blockchain, right? And computer programs are, things that most of us are very familiar with, right? Microsoft Word, Zoom, all of these are computer programs, right? And computer programs are designed to execute instructions by its programmer or creator, right? So a very simple computer program might look like what you see in front of me, where the piece of code could just say, if that event has happened, send party A $1,000. If not, send party B $1,000, right? All the applications that we see on available on Web3 today, DeFi applications, swap applications, automated money makers, loans, bridges. These are all examples of applications created through the use of a smart contract. In fact, even the act of creating a token, minting a token, right, creating a cryptocurrency, all of that is done via a smart contract. Now, again, this is not intended to be a technical course, so we're not going to go into the coding and all of that. But I do want to highlight a couple of things, at least specifically when it comes to token minting. I cannot emphasize enough how easy it is for an individual to create a token, right? This is just a short 1-minute video that I found online by an organization called BitBond, which has basically created their own interface to help somebody looking to create their own token, right? If somebody wants to create their own token using BitBond, all they need to do is go to this website, choose the blockchain they want to create it on, choose the wallet that they want to use. In this case, it could be MetaMask, right? They've chosen Ethereum. Once that is done, all they need to do is decide on a token name, decide on a token symbol, decide on how many tokens they want, how many decimal places they want, whether they want this token to be burnable, mintable, etc. Literally, all they need to do is fill up this form, and once they're done, at the bottom, all they need to do then is to click create token at the bottom, and voila, the token gets created, right? So within less than a minute, anybody can create their own token. So the reason I say that is because in the cryptocurrency space, naturally, it's fraught with a lot of scam projects, right? And criminals are increasingly turning to Web3 and using it in many different ways, right? They are creating malicious smart contracts to exploit people, but a lot of them are simply using cryptocurrency as a way to just launder funds. And why I bring up how easy it is to create tokens is because, I have seen certain instances in the past of individuals being scammed by fake tokens, right? So what do I mean by that? One of the most popular tokens in existence today is a stable coin called USDT, right? A lot of people, when they see USDT, they automatically assume that it is the stable coin USDT Tether. What a lot of people don't realize is, just like what you just saw in that 1 minute video, anybody can create a token and call it USDT. So we've seen instances in the past where, scammers, what they do is they create a USDT token, right? They call it USDT. They send it to the individual and say, hey, I just paid you, $1,000, go and check. Individual goes onto Block Explorer, they put in the transaction hash, they see 10,000 USDT being transacted, and they assume that 10,000 USDT is the same tether, when actually it's a 10,000 USDT that the individual had created that has no value at all, right? So again, I want to point out that cryptocurrencies are simply digital assets. They can be created very, very easily, right? So don't fall into the trap that thinking, all cryptocurrencies are equal. Don't fall into the trap of, assuming that just because the token symbol is the same, that they are referring to the same token as well, right? It's very easy for individuals to create new tokens. If you want to verify that the token is actually the token that you are concerned about, so if you actually want to verify that, hey, this USDT that I'm looking at is the USDT created by Tether, the only way to do that for sure is to verify the smart contract that was used to create the token, right? So for example, if we wanted to look up USDT and, Etherscan actually allows us to do this, we can search up USDT over here and they will actually tell us, okay, this is the smart contract that was used to create USDT. And so if you are conducting a investigation and you are investigating the movement of USDT and that USDT was not created from this smart contract, then that's a good way to then identify that, hey, the USDT that you're investigating is potentially fraudulent, right? Easier ways to identify that would simply be if you look up the token and you saw that, hey, the token doesn't have a lot of holders, hasn't been used much. Again, chances are it was a fraudulent token created for, just a simple scam operation. So that's what I wanted to point out about smart contracts. And then finally, I just have one more short terminology document for you guys before we dive into the tool, right? So quick refresher on some the terms that we covered in the second half of today's workshop. Smart contracts, right? What are they? They're nothing more than computer programs stored inside the blockchain, and they are used to create all kinds of applications, right? DeFi applications, token applications, and so on. We introduced everybody to the concept of a cluster, which I mentioned is very important, right? A cluster is basically a group of addresses which are likely controlled by the same entity or individual. We talked about wallets, hosted versus unhosted. A hosted wallet is simply a wallet software where the private keys are controlled by a third party versus an unhosted wallet where the private keys are controlled by the owner themselves. We have introduced the concept of hot and cold wallet, right? Hot wallets are wallets which are connected to the internet, less secure because, they're always connected to the internet, versus a cold wallet, which is one that is not connected to the internet, right? Yeah. All right, so with that, and with the amount of time that we have left, I want to start going into blockchain analytic tools, right? And actually, before we do that, I do want to actually cover this topic about hops and exposure. So in cryptocurrency tracing and investigations, one term that you might encounter very often is this term of hops, right? Because the blockchain provides us full transparency into every single address and all their transaction history, what that means is we can see all of the transactions that address A has conducted. So we can actually see that wallet A has sent funds to wallet B. But because we can also see all of the transactions that wallet B has conducted, we would then be able to see that, hey, the one Bitcoin from wallet A that went into wallet B then went into wallet C. And in situations like this, we would say that wallet C has an indirect exposure to wallet A, right? Indirect because there's an intermediary wallet of B in between. Or we would say that wallet C is 2 hops from wallet A, right? 1 hop, 2 hop, right? So the term direct exposure, indirect exposure, and the term hops is used very commonly in this industry. And so in this example, we would say that wallet E is 1, 2, 3 hops from wallet A, and wallet D is 2 hops from wallet A. Right? Now, I see a question inside the chat. If we are tracking a wallet that has entered into a cold wallet, how does it go into hot? So great question. Now, a wallet is simply, if you remember correctly, a wallet is simply the software used to store the private key, right? So if a user wanted to move funds from a hot wallet to a cold wallet, in terms of performing the transaction, nothing changes, right? All they need to do is connect to the blockchain and using the wallet software, tell the wallet software, hey, I want to move my funds to wallet B, for example, right? And then they'll put in the address for wallet B, and the transaction would be processed as per usual. So there's no difference in the way that you would conduct the transaction if you want to send it into a hot and cold wallet. Yeah, the only difference is to access that hot and cold wallet, how would you access it? With a cold wallet, you would need to plug in some kind of device to the system because it's a cold wallet. The private keys are stored offline, so you need to plug in that offline device to your system. And in a hot wallet, your private keys are already inside the device, so there's no need for you to attach anything external. But in terms of performing the transaction, exactly the same. It's not more expensive or cheaper to move funds into a hot and cold wallet. It's exactly the same, right? Now, blockchain analytics then. So what is the blockchain analytic tool? What is it trying to do? And how is it different from, let's say, using open source intelligence platforms? So what blockchain analytics tries to do is, we try to analyze all the data from the blockchain and through that provide you guys with a clearer visualization as to how these criminals might be moving their funds. On top of that, we also take a lot of effort to provide the attribution data that we've collected, as well as we also then make available the attribution sourcing data where necessary, right? So this is particularly important at the point of prosecution where we need to provide evidence as to why you are confident saying that funds have gone into, let's say, a Coinbase or a Binance. Blockchain analytic tools will also typically include the clustering that is done by the providers themselves. So if you put in one address, we can then tell you, hey, rather than just investing in that one address, you can expand your service area to these other 50 addresses controlled by the same organization. As well as, as criminals increasingly turn to technology to automate a lot of their money laundering, a lot of blockchain tools today also have, enhanced automated tracing features to help you streamline your investigations, right? And in this next section of the workshop, I will be showing you guys a short demo of how the tool that we've developed look like and walk you guys through a very, very simple case study of how you might conduct an investigation. So the crypto investigation tool that we've developed here at Merkle Science is a tool called Tracker. Right. Now, what you guys are looking at right now is the landing page of Tracker, right? So quick orientation on the left is where you would be able to create files and folders to organize your work. But how you would typically begin an investigation is through this search bar here in the middle, right? Now, directly below the search bar is where you can easily pull up some of the previous work that you've done. And next to that, we have an watched tab. So if you remember, one of the things that I mentioned inside the workshop today is that only somebody with access to the private keys of a wallet can move the funds out. And what that means is that criminals are very comfortable leaving their assets inside a wallet for extended periods of time, even if they know that that address or wallet is being monitored, right? Because unless somebody has their private key, nobody can move the funds out. So within the tool, we do have this feature where you can basically tell the tool to monitor addresses on your behalf and send you a notification when a subsequent transaction occurs, which can then prompt the user to log back in and continue their tracing. Right. But with that said, let's take a look at how a simple investigation might be conducted. Right. So starting point is we can simply put in an address. Now, the moment we put in an address, the tool will immediately give me back some quick results. So in this case, it's telling me that, hey, this address is active on the Bitcoin blockchain. And if I wanted to start an investigation, all I need to do is click Add to Board. And a new investigation board is created with this address visualized in the middle over here. Now, quick orientation about what you're seeing. So directly on the top over here is where you can see the name of the board that was created, and you can rename it where necessary. Directly below it is our toolbar, which allows you to access different features and functionalities. So number one, we have the option to toggle values on the board between fiat and crypto. So depending on whether you want to conduct investigation in native token value or in fiat, you can choose accordingly. We have an undo and redo button, a delete button, create custom cluster, drag, multi-select, legends, preferences, download, annotation, and share. And don't worry, I will touch upon these buttons in a little bit more detail as we go through the demo. Right. So the starting point or objective of most investigations, like I talked about initially, is to find out, where did the money go or who controls this wallet. Now, in this example that I pulled up for you, this was actually a case that was reported to us quite a while back, right, of a victim who suspected that he had been scammed, right? In particular, he suspects that he was scammed into sending funds into an exchange called Hashbot, which supposedly wasn't operational, right? So if we wanted to begin our investigation, all we need to do is click on this address, and immediately we'll have this side panel appear, which provides us information about this address's transaction history, which we can use to begin our analysis. So the first thing that we see is what's called the balances tab. This shows us, how much this address currently holds, how much was sent and received in the past. And like I mentioned, we can toggle all these values between fiat and crypto. Now, next to the balances tab, we then have a summary tab. And what the summary tab shows us is a list of all the entities that we have identified that have either sent or received funds from this wallet, right? And because of the transparency that blockchain provides, we are able to tell you if this address had received or sent funds from businesses across multiple hubs, right? Which means that we're not just restricting our analysis to, A sending funds to B. If A sent funds to B, sent funds to C, sent funds to D, and eventually ended up in this wallet, we would be able to identify that as well, right? So that's what we call indirect exposure. And so if you press a drop down under each one of these, we will also then be able to tell you, okay, was this $18,000 outgoing exposure, was it a direct exposure, of which how much was direct and how much was indirect? We then have a counterparties tab, which shows you a list of all the counterparties that this address had interacted with. And to the extent that we've identified attribution for it, we've also included the attribution name beneath the address ID. And then we have a transactions tab, which shows you a list of every single transaction that this address has done, right? And of course, for every one of these tabs, we also have a filtering option, which allows you to filter based by volume, transaction type, date ranges, and so on. Now, in this case, like I mentioned, it was reported to us that the victim suspected that his funds had been scammed at Hashbot. And so very nicely, if we look at all the counterparties that this address had interacted with, we can actually see funds going directly out to Hashbot over here. So if I wanted to add this to the graph, all I would need to do is press this plus sign, and voila, we would have this visualized on the graph. Now, to kind of explain what we're seeing over here, so in the tool, if you encounter an address that is deemed to be an individual address, we will reflect it as a square. But in the event that we've identified an address being part of a cluster, and again, a cluster is a group of addresses controlled by the same organization or individual, we'll actually represent it as a as a circle like this, right? And so if the user actually wanted to peer into the cluster to see which was the specific address inside the cluster that had received the funds, all they need to do is double click, right? And now we can see the specific address inside this Hashbot cluster that had received the funds. Now, knowing that, okay, about 4.5 thousand was sent into this scammed address controlled by Hashbot, if we wanted to then, in line with the objectives, try to identify who controls the wallet or where did the money go, what we would want to do at this stage is to analyze its outgoing transactions to see, right, where this 4,500 had went. So first thing I want to do is I want to refresh myself on when this transaction happened. So, okay, these funds were misappropriated on December 3rd. Knowing that, I can now look into the Hashbot address, go to transactions, and let's say, now I want to apply a filter to say, actually, just show me all transactions after December 2nd, let's say 2017, right? So now I can choose 2017, December 2nd, and yep, just show me all transactions after the 2nd to be safe. What happened over here? This is start date, end date. Let's say end date 4th. Okay, perfect. So now we have all the transactions that happened between December 2nd and December 4th. And true enough, we can see the deposit coming in over here, right? So this was the 4.5 thousand that was misappropriated. And so what we can see is thereafter that there were 3 withdrawals going out, of which 2 seem to be quite significant. And it seems like it was just, him splitting this amount into 2 separate withdrawals. So what I'm going to do is I'm going to go ahead and press the plus sign next to these 2 addresses and have them shown on the board as well. Now, to be completely honest, everything that we've done so far could be replicated on an Explorer, right? Which means that I could have taken this address, gone to Bitcoin Explorer, searched it, and I would have seen the withdrawal going out to Hashbot, which is the address ending with MDA. Right. So I could have seen the withdrawal coming out to this address over here. I could have clicked on this address, pull up all the transactions conducted by this Hashbot address. And if I go down, I could do the same thing and I would be able to see the withdrawals going up, right? So everything that can be done in the tool can be done on an Explorer as well. The tool just makes it easier and it provides a better visualization as well as overlaying that with obviously attribution, right? So in this case, as I see the money coming out from this Hashbot address and being split into these 2 addresses, I can repeat the same steps that I have done previously. So again, I want to try and find out who controls this wallet. And very nicely over here, actually, when I look at the counterparties, I can actually see that, hey, funds have directly gone out to Bitfinex, which is an exchange with mandatory KYC and AML. So if my goal was simply to find out who controls, this Hashbot wallet, then this act of following the money into this wallet and going into Bitfinex already provides me with my first avenue, right? Because knowing that funds have gone into BitMEX and knowing that BitMEX is an exchange with mandatory KYC and AML, and I do believe they're also based in the US, so in a very nice jurisdiction that would be responsive. At this point, I am able to, if I wanted, submit my first request to try and identify who controls this wallet, right? So what you typically do at this stage is, if you wanted to, you would write into Bitfinex, you would provide them this address information, which is the address inside Bitfinex that had received the funds. And in fact, if we look at the deposit amount, the withdrawal amount, this tells us actually very neatly that this is very, very likely to be a Bitfinex user deposit wallet, right? So it's ticking all the boxes in my mind. Okay, great, it's gone into a Bitfinex user deposit wallet, which means that this is an individual wallet, which hopefully Bitfinex has KYC information on. So I'll want to write into Bitfinex, provide them this address. If I want to be a little bit more complete, I would also want to provide them this transaction hash and some background as to the whole case and why I think the funds have gone into this account. Now, within the tool, in order to assist with this outreach, we do have a directory feature at the top where we've taken efforts to try and collect information from different VAS. So if you were looking to reach out to Bitfinex, it is possible that you could look up Bitfinex within the tool. If it's an entity that we have investigated in the past, you would then be able to pull up information about it, right? So in this case, you can click Bitfinex, and then we will provide you, let's say, their email over here, right? So this is where you could write in for information about the user. Now, let's say, maybe Bitfinex was not too responsive, right? Or they didn't have, accurate information. Well, we would simply then repeat this exercise and continue our investigation, right? So aside from funds going out directly to Bitfinex, we actually also see a good amount going out to other wallets. But let's say, we didn't find anything else notable. We could also expand our investigation surface area to this other wallet over here, right? So again, I'm going to repeat the same steps. I'm going to look at, maybe the transactions first. Very nicely, I can see that, hey, most of the funds seem to have gone out to this wallet over here, right? So after all the funds went in December 4th, there was a period of no activity, and then the next significant withdrawal happened on March 20th. So I'm going to go ahead, press this to map it out on the graph. Again, I see it coming out, click on the next address, go to transactions. Oh, and in this stage, okay, very nice. I can see a large amount going out to Binance. So again, I'm going to map this out on the tool, double click into the Binance cluster to see the specific Binance address. And so I would repeat the exact same steps with Binance, right? I would, collect this information, write into Binance, and ask them to provide information about who controls this wallet. Right? Now, interestingly enough, I saw that this wallet over here had done a number of other significant withdrawals, right? Of 90 Bitcoin, 50 Bitcoin, and so I am going to just add these all to the graph as well to see if there's anything interesting that I might observe. And true enough, when I add these three addresses to the graph, what I then observe is, hey, these addresses, and I'm just going to go ahead and annotate these as well. These two new address withdrawals that I added to the graph, the lines that we see in red and blue, interestingly enough, after they received the funds, both of these wallets were also sending the funds into the same Binance deposit wallet that we see over here, right? And this leads me to assume that, hey, chances are these three wallets, they're probably controlled by the same individual, right? He was probably moving it to, these two wallets to try and create some layers, but he's at the end of the day still funding or cashing out all his cryptocurrency in the same Binance user deposit wallet. So given that I assume maybe these three wallets are part of the same organization, one of the features in the tool that you can use is what's called a multi-select. So I can select these 3 addresses, and I can then create what's called a custom cluster, right? So I could create a custom cluster and say, suspected group of addresses controlled by same person. All I need to do then, save name, and voila, tool has now created a custom cluster made out of these 2 addresses, which I can collapse if I want for graph hygiene purposes, right? So the beauty of the tool is not just on the attribution side, but it's also the ability to kind of manipulate the data so that to help better organize your train of thought and to see how these funds are being moved. Now, this is an example of how you would conduct the investigation manually, right? But if you remember, I did say that one of the beauties about blockchain analytic tools is also the ability to leverage on some of the automated tracing capabilities. So within Merkle, we take the same address again, and again add it to a new board. One of the features that I didn't introduce to you guys that I want to introduce you now is our feature called Auto Investigate, right? So within the tool, if you remember, the summary page shows you all the entities that we've identified that have direct or indirect interactions with this address. And so if we know that this address was scanned by a hashbot, if I wanted to visualize this on the graph, all I needed to do is I could just press the plus sign over here and it would map it out for me, right? Now, this is pretty straightforward. But what is different is rather than me having to, kind of manually map out the trail into Bitfinex, manually map out the trail into Binance, with the Auto Investigate feature, when we go to the summary tab, right? So we wanted to know where the funds are leaving this hashbot wallet and ending up in exchanges, we can actually just rely on the summary tab. Summary tab is telling me, okay, 4,175 is ending up in Binance. Rather than me having to manually, map out each transaction individually, I can simply click Auto Investigate and rely on the tool's algorithm to actually identify the transaction pathways and map it out for me, right? So as you can see, this is actually the end result. What I had thought was a fairly simple investigation, right? So what I had thought was a fairly simple investigation of funds coming out from Hashbot, going through, these different intermediary wallets and ending up in this Binance wallet was actually not as simple as I thought, right? So when I relied on the algorithm instead, where it would literally investigate every single transaction coming out and investigate every single possible intermediary wallet that was utilized, the end result was actually funds originating from Hashbot did not just take that tree hop pathway into Binance that we saw in the previous graph, but in fact were laundered through many different wallets before going into 5 different Binance deposit wallets, right? Now, this would have been possible for you to achieve the same outcome if you were, manually mapping out every single transaction trail in order to get a complete graph. But this is really what I mean by relying on tools to automate your investigation. Because oftentimes one of the biggest pain points for investigators is they would have to investigate every single transaction, not knowing if it would eventually end up in an exchange that could yield them some useful insights. Whereas with a lot of the tools out there today, we tend to use algorithms to perform that investigation for you and kind of tell you if you can expect something at the end. And if you can also rely on the tool then to kind of automatically map it out for you rather than have to kind of manually perform this exercise because it can be very, very time consuming. Now, obviously, Auto Investigate has its own limitations as well. While it is pointing out all the different ways in which funds could have moved, at the end of the day, it is still up to an investigator to go through each transaction and eliminate based on the facts and circumstances available to them, right? Now, once you are done with an investigation and you are called upon to, let's say, produce a report, Within the tool, and this is present across all the tools out there, there is then typically the ability for you to export information about an address. This could be, transaction histories, counterparty histories. On top of that, there is also the ability for you to download any of these graphs as images, as well as one of the challenges that we've heard from a lot of our partners in the crypto space is oftentimes because of the lack of resources from different agencies, cross agencies collaboration can also be very challenging, especially when the corresponding agency may not necessarily have access to a tool. So within our tool, one of the unique features is that we have created this ability for users to actually share their investigation board externally by being able to generate what we call a public URL. And so just to be clear, anybody who shared this URL will be able to pull up your investigation graph, see the great work that you've done. And of course, if you are concerned about privacy, there is always this ability to kind of password protect your work. Right? So I just do want to point that out for you guys as well. Other thing that I wanted to point out as well is if you are requiring the tool to monitor an address on your behalf, at the top, this is where you would typically access the watch list function. So if you wanted the tool to monitor an address and send you notifications, this is how you would do so. And we do allow you to be very specific as to the type of notifications you want to receive. Is it only for incoming, only for outgoing? Do you have certain dollar value thresholds or certain transaction types that you're concerned about? Right. Now, there's a question that has come in. With the auto investigate, is it just mapping every transaction out of the investigation address, or can you make it follow a first in, first out investigation? So great question. Today, our auto investigate feature is mapping out every single transaction. The only parameter that it takes into account is date and time, right? Which means that it will make sure that any preceding transaction must happen before the next transaction. That being said, today it does not follow any accounting tracing principles, but it is something that we are working on, right? So in fact, just to kind of share with you, rather than FIFO, we are actually starting with LIFO. LIFO seems to be the more common accounting approach that is being taken over here, but closely linked to that, we do intend to eventually support both LIFO and FIFO. So what I've just shown you guys is an example of a very, very simple cryptocurrency investigations. Cryptocurrency investigations can grow and be a lot more complex. We've seen cases involving, hundreds, if not thousands of addresses, right? And so it can be a lot of data for an investigator to kind of go through manually. And so having a tool definitely helps. I also want to emphasize that, what I covered today in terms of crypto investigations is probably less than 1% of what you would need to know as a full-fledged crypto investigator. There's a lot more information that I've not covered. I've not gone into depth on Ethereum-based investigations. There's a lot more that we can cover in smart contracts. And the point that I'm trying to make is the more that you can educate yourself on the technology, it will lend a huge advantage when it comes to you conducting investigations, because there's a lot of technical nuances that can assist in helping you interpret the data when it comes to crypto tracing and investigations. Last thing that I want to show you guys in the tool before we go back to just some last tips that I have for you is that, with the tool, we do try to automate as much as possible. And on top of just having features around, auto investigate, we do also have features to help users around, cross-chain tracing. So in the event that, you are investigating an Ethereum-based address that has, let's say, leveraged a bridge to trying to obfuscate its funds onto a different chain, within the tool, we have tried to simplify that for you as much as possible. So any time you see a bridge transaction, within the tool, we'll actually identify that transaction as a bridge transaction for you. And when it comes to mapping it out on the tool, again, We try to simplify the work for the investigator by just directly helping you connect the dots as to where the funds had started out and where the funds had ended up, right? So in this example, you see funds moving from Polygon Matic to the Ethereum-based blockchain. And again, we try to automate that bridge support for you. So with that, I know from speaking to my colleagues that had helped put together this training, I do believe that everybody part of this training should have access to the tracker tool to play around. That being said, signups was better than we intended. So there may be a few of you who had signed up last minute. And so maybe my colleague had not had an opportunity to reach out to you to offer you access to the tool. If you don't have access to the tool, do feel free to reach out after the training. And as part of this, we are making the tool freely available for a period of time. So last couple of maybe tips from me before we break. Information to provide invest, right? So using the tools are great, but at the end of the day, if you want to seize the funds or if you want to identify who controls a wallet, you will be forced to work closely with VAS who can provide this information for you. So I want to give you guys some tips as to how to make this experience as seamless and as useful as possible, right? So thankfully, most exchanges today have woke up to the importance of collaborating with law enforcement and regulators. So most of them are pretty responsive. That being said, it is important that you provide them with accurate and complete information so that they can also give you back the information that you're looking for. So our tips to law enforcement reaching out to VAS, number one, always make requests via your official work email domains, right? If it's not from an official government email domain, there's a very low likelihood of them responding. When making a request, please always include, full information about yourself, your name, your position, your contact information. Where possible, it's always good to be able to attach, official letterhead requests, prosecution's requests, court order, if possible. What I will say though is that time is of the essence with a lot of these cases, right? And I do know that it can be challenging to get a court order sometimes. So don't let the absence of a court order hold you back from reaching out to an exchange. In our experience, a lot of the larger exchanges, Binance, Coinbase, for example, as long as you're writing in with a official government email and an official government letterhead, they're more than happy to freeze an account, no questions asked, for 2 weeks at a time, right? Which then gives you the time you need to apply for a court order, right? So the moment you suspect funds going to an exchange, just send them an email in, with as much information as possible, and there's a good chance that they will freeze the funds for a period of time. Do give them a description of the suspicious activity, as much information as possible. But that being said, do limit your request to a reasonable amount of wallets and transactions, right? Because typically what happens is when you submit this information to them, the exchange would typically have their own intelligence team kind of review the request to see if they can find out anything more about the address. And so if you're sending them, 1,000 wallets or 1,000 transactions, as you can imagine, it's unlikely that they are even going to bother going through everything, right? So do try to limit your request to a reasonable amount. And as much as possible, if you can provide them deposit and withdrawal address, transaction hash, any date, email, as much as possible, any information about the victim or associated wallets, please do include it as well, right? And ideally, this would also be provided in clear text or a CSV or Excel format. Now, if you are successful in providing all this information to them, what you can expect to receive from these exchanges, depending on whether or not it's a KYC or non-KYC account, could include things like the user's email address, the deposit and trade history, withdrawal history, IP logs, device logs. Where the account has been KYC, chances are you could also get access to, passport, ID, driving license, and in some instances, you could also get access to cookies or an account ID. I do want to preempt that, not all exchanges collect the same information. Some exchanges collect way more than others, right? So it's always good to, when you make a request, just request for as much information as possible, because again, you may not be sure what you get back, and you definitely don't want to limit your responses to just what you think they can provide. So with that, I know we are coming up on time. So as much as I have, prepared some additional information for everyone, unfortunately, due to time constraints, I will be bringing the workshop to a close. Before I do so, I do want to leave maybe one last minute to see if there's any final questions that have come in from anyone. So if you do have any final questions, please put them inside the chat. For those of you who have additional questions that perhaps we were unable to answer in today's call, please feel free to reach out to me via email, and I'm more than happy to jump on another call to address them. For those of you who are interested in trying out the tool, like I said, please feel free to write into us at Merkle. We're more than happy to assist. And again, I want to thank everybody for being a great audience. Right, I hope you found today's session useful. We are intending to do more sessions in the future, so we will keep you guys updated for future sessions. But if you guys have any thoughts as to what you would like us to cover in future sessions as well, by all means do write in, and we're more than happy to see if we can include that in the future. With that, again, thank you everybody for attending today's workshop. I hope you found it useful, and I wish everybody all the best.